In this video, we're going to quickly look at how we might convert a binary number to its hexadecimal equivalent. So let's say we want to convert this big binary number here into its hexadecimal equivalent. What we want to do is we want to look at the bits, write them out, and then starting at the right-hand side, we want to group them in groups of 4. So you start at the least significant bit, grouping into groups of 4. This is because you can directly translate 4 binary bits into one hexadecimal digit. Okay, so we can say, okay, here's our first group of 4, our second group of 4, and then we have 2 leftover bits. So we could just fill that on the leading edge with zeros, or just deal with it as it is as a group of 2. But it's okay that it's not exactly divisible by 4. Then the next thing we do is we want to separately for each individual group look at the decimal equivalent. So we're going to go decimal as an intermediate step. So here you can say, okay, we have a 2 to the 1 plus a 2 to the third. That's 2 plus 8 is 10. Here we have a 2 to the 0, actually, plus a 2 to the 2 plus a 2 to the third, which is 1 plus 4 plus 8. So that gives us 13. And then here we just have a 2 to the 1 is 2. Okay, so now we have the decimal equivalents for each of these groups of 4. Then what we can do is we can convert these to their equivalent hexadecimal digit. So 10 is A in hexadecimal, 13 is D, and 2 is just 2. So then we can combine these and say that this big long digit in number in binary is equivalent to 2DA in hexadecimal, or base 16. Another thing that we can do is if we don't want to go through the step in the middle where we convert to decimal, we can just look the equivalencies up on a chart, right? Or after a while, you might even find that you just kind of remember them from using them. But this is the sort of general procedure. You can also use a chart, or you can just start to recognize patterns of bits as you use them.